Okay, this is section standard 1.4b, learning target of finding the 5 trig values given 1 trig ratio, and some additional information. Once again, I've just highlighted the big ideas we kind of need heading into this. So the first thing we need to do is understand where each of our functions are positive and negative on the quadrants for the coordinate axes. And again, these are based off of the right triangle circular trig definitions. So based off of this and the fact that x's and y's are positive and negative in the various quadrants, because x's are positive here in quadrant 1 and y's are as well, that means that sine, which is dependent on the y, and cosine, which is dependent on the x, are positive, and then the ratio of positive to positive is positive, and then all the reciprocals are also positive. Continuing on to quadrant 2, where the only thing that's negative is the x value, and then the ratio of y to x would also be negative. So the only positive function in quadrant 2 has to do with the y's, so that would be the sine value and the cosecant value, and this continues. Also, I wanted to remind you of the fact that the radius is always a positive value. And then, of course, of the definitions of each of our functions in space. So that being all said, the next thing we want to look at is an example of what I would be looking for in a question like this and how we process that. The idea is that if we have some value of 1 trig functions, in this case that the sine of t, which is theta, equals negative 2 over 5, and we know that the cosine of t has to be greater than 0. Based off of that, we want to find the remaining 5 trig functions. It doesn't seem like a lot of information has really been given here, but in fact it has. We know from our definitions that the sine of t equals y over r. And we also are told in this particular example that that equals negative 2 over 5. So as a result, we can make some conclusions here. We can conclude that the 2 is the y value and the 5 is the r. And of course, there is the issue of the negative sign out in front. So we know that the radius is always positive. That's an important fact here. So the 2 must be the negative and the 5 must be the positive. So we know that y is negative 2. And r is positive 5. The other thing that we know is that sine is negative and cosine is greater than 0, which means cosine is positive. So in order for me to answer for the values of the remaining functions, I need to know what quadrant I'm in, because I need to know which of my functions overall should be positive and negative. So we have sine negative. Actually, let me do that in a different color so it stands out as different work. We know that the sine value is negative. And based off of our work over here, we know that sine would be negative in one of these two quadrants. Y's are negative below the x-axis. And we also know that cosine is positive, and by looking at our chart over to the right, we know that's true in quadrants 1 and 4. So it looks like our overlap quadrant is quadrant 4. So in this particular example, the function that we are talking about must be lying somewhere in quadrant 4. So I'm going to draw my reference triangle in quadrant 4, labeling the theta as the reference to the closest x-axis, drawing the triangle up to the x-axis as well, and based off of the work that we just did right here, we know that the y value there is negative 2 and the r value is positive 5. This kind of jives with what this looks like because the y is going down, so it makes sense that it's negative, and then the radius is 5. Just like what we did when we were given a point in space, now we know two sides of a right triangle, and we need to figure out what the third side is so that we can evaluate the remaining trig functions. So in order to do that, two sides in a right triangle, we want the third. The x is what we don't know, so I'm going to say x squared plus negative 2 squared equals 5 squared. So this is working off Pythagorean theorem. So I get x squared plus 4 equals 25. I get that x squared is 21, which means that x is either positive or negative square root of 21. In this particular instance, my x value is going to the right of 0. To the right of 0 means that it's positive, so this is positive square root of 21. So if I'm looking at my labels in terms of my x, y's, and r's, I can say that this is the left of 0, so that's x. This is going down, so that's y, and then this side over here is r. That's all the groundwork that we need to have laid. So now we can go ahead and go on with identifying the other trig function values. I'm going to start with cosecant because that went with sine. So we were given that sine of t was negative 2/5. So that means its reciprocal cosecant of t must be negative 5/2. Cosine of t is x over r, so that's square root of 21/5. And its reciprocal, secant, is the reciprocal of that, so it's 5 divided by the square root of 21, which we have to rationalize, so that ends up becoming 5 square root of 21/21. Oh, it's not working out there, so let me fix that as best I can. So 5 square root of 21/21. And then our last two functions are tangent and cotangent. Tangent is listed as being y over x. So in this picture, that is negative 2 divided by square root of 21, which again I have to rationalize. So that gives me negative 2 square root of 21/21. And its reciprocal cotangent is, I'm going to go ahead and take the reciprocal of this step here. And I get negative square root of 21/2. I noticed that I used a theta here instead of, so let me do that, instead of the t, so I'm just going to, don't want to confuse you there. So those are the remaining 5 trig function values given the 1. So again, not dissimilar to finding the 6 given a point in space, but again, we have additional legwork up front about figuring out how to draw, where to draw the reference triangle, and then figuring out in terms of the fraction that was given to us, what two pieces of information are given, x and y, x and r, y and r, etc. And that is finding the 5 trig values given a 1 trig ratio.